to lesson 4-3, part 2, solving systems of equations by elimination. In the example number 2, we're looking at understanding equivalent systems of equations. So we are going to be verifying if a solution is true for a system of equations. And there's going to be a few methods we're going to use. So we are asked to verify if the solution of x is equal to 1 and y is equal to 2, and here it is as an ordered pair, if this solution does indeed satisfy the system of equations. So we're going to look at this first method called substitution. So we have our x coordinate is 1 and our y coordinate is 2. And we are going to substitute these values into the two original equations, starting with the first one. X plus 3y is equal to 7. If I replace the x with the 1 and replace the y with the 2, I want to know, does it equal 7? So I'm going to put a question mark here. So then I just do the math. I have 1 plus 6. And I know that 1 plus 6 is 7. So 7 equals 7. The solution of 1 comma 2 does satisfy the first equation. Let's see if it satisfies the second equation. We have 2 times x. We know x is equal to 1. Plus 2 times y. We know y is equal to 2. And I want to know, does that equal 6? So this is 2 plus 4. And 2 plus 4 equals 6. So therefore, it does satisfy both of these equations. So let's write that in a sentence. The solution 1 comma 2 satisfies both equations. Okay, let's look at another method. If we take this system of equations and we graph it, we want to see, can we see the solution when we graph it? Do they intersect at 1 comma 2? So I'm going to first graph this top one here. I'm going to take that one and I'm going to convert it to slope-intercept form. So that means solve for y. So if I move the x over, I have 3y is equal to negative 1x plus 7. All I did is subtract x from both sides. Then to get y by itself, I am going to divide by 3. So I end up with y is equal to negative 1/3 x plus 7/3. So starting with the y-intercept of 7/3, 3 goes into 7. 2 times there's 1 left over, so that's 2 1/3. That's about right here. My slope is negative 1/3, so I can go down 1 and to the right 1, 2, 3. I can also go up 1 and to the left 1, 2, 3. So if I sketch a line going through these points, this one here represents x plus 3y is equal to 7. And then I'm going to take this second one. Because it is in standard form, I'm going to just solve for the intercepts. So to find the x-intercept, I have 2x is equal to 6. To find the y-intercept, I have 2y is equal to 6. If I solve both of these for the variable, on this one x is equal to 3 and y is equal to 3 is the same thing. So I'm going to go to the x-axis and put a point at 3. And then, or sorry, the x-axis, but it's the same thing as at the y-axis. So if I sketch a line between these two values, my line for the equation 2x plus 2y is equal to 6 is this red line. And you should notice that they are intersecting at this point right here, which happens to have the coordinates of 1, 2. So this is another confirmation that this solution satisfies both systems of equations by graphing. Okay, let's look at an option B. It says create an equivalent system of equations to be able to eliminate or to be able to use the elimination method. So same system as before. X plus 3y is equal to 7. 2x plus 2y is equal to 6. We're going to follow the steps here on the side. If I look at this carefully, I notice that there are no coefficients that are opposite. So there's something we can do to make the coefficients opposite. If this x were a negative 2x, it would be opposite of a positive 2. I can also try to create the y's opposite coefficients, but I'm going to go ahead and make the x's opposite coefficients. So then I have to multiply the entire equation to make an equivalent equation by negative 2. When I do this, I'm distributing to all the terms into the equation, including the 7 over here. So if I multiply that out, my new equivalent system of equations will become negative 2x minus 6y is equal to a negative 14. My second equation remains the same. I did not have to multiply that by anything. So I'm going to write it as 2x plus 2y is equal to 6. Here, now we should notice that we have opposite coefficients. Since those are opposite coefficients, that allows us to eliminate the x variable, solving for y first. 6y plus 2, or a negative 6y plus 2y is negative 4y. Negative 14 plus 6 is a negative 8. To continue to solve for y, I am going to divide both sides by the negative 4. Therefore, y is equal to a positive 2. Now I'm going to take this 2 here, and I can either substitute it in for this y here or this y here. It doesn't matter which one we choose. And I'm going to go ahead and just go with the first equation. So x plus 3 times whatever y is equal to 7. Well, we're going to substitute in the value of 2 in for y here. So my new equation only has the x variable, so we're going to solve for that. So this becomes x plus 6 is equal to 7. Then I subtract 6 from both sides, and x is equal to 1. So we see that on this one, the coordinate 1, 2 also satisfies the system of equations. So for the remainder of this lesson, we're going to look at creating equivalent systems of equations that will allow us to use the elimination method to either eliminate the x-coordinate or the y-coordinate. This next section of the notes for now, I am going to just cross it out. We'll come back to this later in the lesson.